Hi, this is Matthias and Andreas from Saarland University, and we're here to show you how to automatically learn the structure of an input with our AUTOGRAM tool. Fuzz testing is a means of testing computer software. The idea is that you create a bunch of random strings and you feed them into a program that would then crash. This worked pretty well until the late 2000s. Modern programs, though, are more robust. When faced with garbage input, they simply bail out. No fuzz testing for you. However, if you know about the structure of the input, you may be able to create inputs that are not so easily refused. The rules that describe such a structure are called grammars. In 2012, we would use such a grammar for JavaScript, like the one shown here, to systematically fuzz JavaScript interpreters in common web browsers. This brought a lot of crashes, a lot of bugs, and a lot of money too. The problem, however, is where do you get the grammar from? It takes a lot of time to write them. This is why we invented AUTOGRAM. We feed some legit input to a program. AUTOGRAM observes how the program processes the input and derives a grammar. This grammar can then again be used by a fuzzer to produce even more inputs. How does learning grammars work? Let us assume a very simple program that takes as an input a web address, also known as a URL. A URL comes in several parts. There's a protocol, a host name, a port, possibly a login, a page request, and a bunch of so-called terminal symbols. All these different parts are processed in different functions in the program and stored in different variables. Here's such a real program. This is the method java.net.url.set, which is part of the standard Java URL parser. When the class passes a URL, like the one above, it invokes this set method with the original input already split over multiple parameters. The protocol, for instance, is passed in a parameter called protocol. The host name, here google.com, ends in a variable named host. Same goes for the user info, going into user info, port goes into port, the path goes into the path, the query goes into a variable named query, and the fragment, if any, ends in a variable named ref. There's also a variable named authority, which is composed of multiple of these, and the general URL program therefore also processes all these inputs at once. Now the interesting part is that part of what the URL function processes as a whole is composed out of its individual parts. The protocol part can be seen here, and this is how we can derive that a URL overall starts with a protocol. The next part, user password, is actually part of the authority, so we can derive that the next part of the URL is called an authority. And the authority itself starts with a user and password combination, so this is again something we can derive. And the authority ends with a host name, which we therefore also can derive into our grammar. All in all, we now get a grammar as seen below. And note how the grammar non-terminal names are all directly derived from the parameter names, making them very readable. Now if we feed in more URLs into the system, the grammar generalizes to match multiple inputs. And this can then be used to generate millions of URLs, all for fuzzing. Here's the first 1,000 URLs as produced by our system. Generally speaking, AUTOGRAM needs just a Java program and a set of sample inputs. This is how we derive, say, the grammar of so-called ini files, which come as key-value pairs, or JSON files, which contain matched parentheses and nested structures. Again, all of this is the raw output, very close to what a handwritten textbook grammar would look like. In the long run, we want to be able to automatically analyze thousands of file formats, including, say, archives, CAD formats, graphics formats, office formats, game formats, program formats, and eventually fuzz them all. So, what we got here is a tool that could help a lot in reverse engineering of file formats, be it for writing tests or for writing parsers. The most important thing, though, is that it opens entirely new ways to systematically test programs by creating millions of pretty legit inputs in all kinds of formats. Thank you for your attention. For more details, please visit our webpage.